Today, we are looking at the first autonomous AI robot to definitively defeat elite professional human athletes. We are tracking a staggering $23 billion AI factory lease that is actively rewiring the power grid. And we are diving into massive agent swarms executing thousands of digital corporate tasks in parallel. Let's get straight into the landscape we are operating in today, because it has just violently shifted. We are no longer just talking about chatbots answering trivia or politely drafting emails. Those days are long gone. The gap between digital intelligence and actual physical execution is vanishing. AI is taking autonomous action in the physical world. It is running multi-day corporate workflows, and it is triggering massive geopolitical infrastructure shifts. But as we are about to see, crossing that barrier brings a completely new set of human, corporate, and regulatory speed bumps right along with it. Let's start with the most visceral example of AI crossing into the physical world: Sony AI's Project ACE. For 43 years, scientists have been trying to build a machine that can actually play ping pong. It seems like a simple parlor game, but computationally and physically, it is an absolute nightmare. You are tracking a tiny, fast-moving object and calculating the exact force and angle to return it. It requires real-time physics calculations that traditional robotics simply couldn't handle without cheating, like shrinking the court or asking the human player not to use spin. But Sony just debuted Project ACE. Under full official Olympic-sized court rules, this robot defeated professional human athletes. The hardware specs are mind-bending. It uses 9 cameras to triangulate the ball in 3D space, taking 200 snapshots per second. But the core of how it processes that visual data relies on 3 specialized cameras using something called event-based vision, specifically the IMX273 sensors. To understand why this matters, think of a standard camera like a security guard assigned to watch a massive, completely empty parking lot. That guard has to scan every single square inch of the pavement over and over all night long, just in case a car pulls in. It is exhausting, requiring massive amounts of energy and processing power. Event-based vision, on the other hand, is like a motion sensor light. It only flags the specific pixels in its field of view that actually change in brightness. It entirely ignores the static background of the room and only processes the moving ball. It is so precise that it actively watches the printed logo on the ping pong ball as it flies through the air just to calculate the exact rotational spin. That focused processing is what gives it a 10.2 millisecond latency. You literally cannot blink before it processes your shot. The robot is returning 75% of shots against spins of 450 radians per second, which means the ball is doing about 72 full rotations per second in midair, and it handles it effortlessly. Here is the detail that really changes the game. This robot trained entirely in a simulation. It is a concept called zero-shot transfer, relying heavily on deep reinforcement learning. The engineers built a highly accurate digital physics engine, essentially a video game, and let the AI brain play millions of virtual matches using trial and error. Then they dropped that digital brain into a mechanical body, and it instantly understood real-world gravity and aerodynamics without any physical practice. Now, some technology critics, like John Billingsley, who ran the first robot ping pong contest in 1983, push back on this. He called Project ACE a mob-handed sledgehammer technique. His argument is that if you throw custom silicon and endless engineering hours at a single ping pong table, of course the machine will win. But dismissing this as brute force misses the broader implication. Sony AI's chief scientist, Peter Stone, views Project ACE not as a ping pong product, but as an Apollo program for physical AI. The goal isn't to sell ping pong machines, it is to master high-speed, adversarial physical interactions in real time. It proves the simulation to reality pipeline works, paving the way for advanced industrial manufacturing and dynamic domestic robotics. If a machine can perfectly track a microscopic logo on a spinning ball in the physical world, what is it doing with visual data in the digital space? That brings us to OpenAI's new ChatGPT Images 2.0. Generative AI has notoriously struggled to spell words on signs or menus, usually spitting out weird alien gibberish that vaguely approximates the shape of letters. Images 2.0 fundamentally changes how the model maps semantic meaning to visual pixels. It renders small text, UI icons, and flawless details in multiple non-Latin languages, including Japanese, Korean, Chinese, Hindi, and Bengali. And it goes way beyond making pretty pictures because OpenAI added reasoning modes. It can browse the web for context, turn raw uploaded data into detailed visual explainers, and check its own visual output against your prompt. Developers are already using it in the Codex app for Mac. They take flawless image mockups, feed them into the model, and the system automatically generates working user interface code. Taking a visual concept and autonomously translating it into working software is the perfect bridge into how corporate labor is shifting right now. Because if an AI can perfectly analyze a screen and execute physical tasks, the next step is operating our digital workspaces. And how does it learn our daily desk jobs? It watches us. Meta just launched an internal tool called the Model Capability Initiative. They are actively tracking the keystrokes and mouse clicks of their own employees to train AI on how humans navigate everyday enterprise software. The surveillance aspect is intense, especially when you consider Meta has already cut roughly 2,000 jobs this year and reduced their open job listings from 800 down to just 7. Tracking the exact mouse movements of the remaining staff is observational learning at an enterprise scale. The goal across the industry is the transition from chatbots to autonomous agents. A chatbot waits for you to ask a question. An agent is given a broad goal and operates independently to achieve it. OpenAI just launched Workspace Agents, powered by Codex, that live 24/7 inside a company's Slack environment. They triage software requests, draft follow-ups, and run deep accounting reconciliations without any human prompting. But the industry standard for these long-running tasks right now is Anthropic's Claude Opus 4.7. The differentiator is its self-verification loop. Think about building a house. If a carpenter measures a piece of wood incorrectly on day 1 and uses that flawed piece to measure the next one, the error compounds. By day 30, the house collapses. When an AI agent performs a task with 100 steps, a tiny hallucination at step 3 compounds into a massive failure. Opus 4.7 is designed to pause after every single step, reference its current state against the original prompt, and verify its own logic before moving on. Quality control is baked directly into the architecture, and we aren't just talking about single agents anymore. Moonshot AI just launched the Kimi K2.6 agent swarm. You assign this system a task, and it unleashes 300 sub-agents that operate in parallel, executing up to 4,000 steps per session. You aren't just getting an email draft. You are getting a 100,000-word research report or a data set with 20,000 perfectly formatted rows, generated simultaneously by agents scraping, coding, and analyzing. We are seeing complete digital corporate divisions operating at machine speed. Even the management of these systems is being automated. Jerry Tworek, a former OpenAI researcher, just launched Core Automation with the explicit goal of building an AI lab that automates its own R&D. This lines up perfectly with a massive new patent from Cognizant. Patent number 12,566,942 outlines a method that allows neural networks to self-tune their own activation functions. An activation function is basically the plumbing valve of a digital neuron. It is the mathematical threshold determining if a piece of information is important enough to pass along to the next layer of the network. Historically, human engineers had to guess, test, and hard code these valves through trial and error. Cognizant's patent enables automated machine learning, where the AI dynamically designs and refines its own mathematical thresholds. The machine is literally inventing new math to govern its own brain structure. Think about the scale of this. AI tracking human mouse clicks to learn workflows. Swarms of 300 digital workers operating 24/7. Neural networks dynamically designing their own internal logic. It is fundamentally transforming humans from makers into orchestrators. The primary value of an employee isn't writing the Python script anymore. It is defining the strategic goal, deploying the swarm, and rigorously verifying the output. But orchestrating that parallel digital labor requires raw compute power on an unprecedented scale. We are in the middle of an infrastructure gold rush. Applied Digital just signed a $23 billion lease for an AI factory called Delta Forge 1. It is a 430 megawatt facility. To contextualize that, you are looking at the power consumption of a mid-sized city channeled entirely into one building just for AI processing. And that is just one site. Anthropic and Google Cloud partnered to bring over a gigawatt of capacity online using 7th-generation Ironwood TPUs for the Claude 4 and Mythos models. Why TPUs instead of the standard CPUs in our laptops? A standard central processing unit is like a highly educated professor. It can solve incredibly complex problems, but it does them sequentially, one at a time. AI models don't need sequential logic. They rely on massive matrix mathematics. A tensor processing unit, or TPU, is a specialized chip built specifically for this math. It operates more like an army of elementary school students performing millions of basic addition problems simultaneously. To train these frontier models, you need gigawatts of power feeding hundreds of thousands of these specific chips. The geography of this compute is shifting global politics. Microsoft is investing $17.9 billion into AI infrastructure in Australia alone, covering Azure AI expansion and cybersecurity. Cloud computing is no longer just IT infrastructure. Where you build the data center dictates where the optimization happens. These server farms are national-level strategic assets, and the Asia-Pacific region is the current battleground. But all of that metal, silicon, and electricity is completely dormant without the human genius required to program it. Hardware is commoditized, but talent isn't. Look at Tencent. They just launched Hi3, a powerful new AI model integrated across all their consumer platforms in China. They built it incredibly fast through aggressive poaching, hiring elite researchers directly away from leading Western AI labs. The mobility of a few hundred human researchers is actively dictating the balance of power in the US-China AI rivalry. And look at Elon Musk. SpaceX just bought a $60 billion option to acquire the AI coding startup Cursor. Musk's XAI has been losing ground to models like Claude Code and OpenAI's Codex, so he is leveraging SpaceX's massive Colossus compute cluster to guarantee $10 billion to Cursor, buying his way into a frontier coding tool by acquiring their elite talent. Meanwhile, OpenAI is sitting quietly, teasing a project codenamed Spud, widely suspected to be GPT 5.5. The dynamic playing out is identical to a high-stakes professional sports draft combined with an energy grid monopoly. You can build the most expensive stadium on Earth and secure gigawatts of power, but if you don't draft the MVP researcher to design the model architecture, you lose the game. But as all this money, talent, and autonomous execution collides, the real world is starting to put up speed bumps. We are hitting some deeply human problems, and the collision between autonomous agents and human governance is messy. The prestigious law firm Sullivan and Cromwell learned this the hard way, formally apologizing to a federal judge after submitting court documents filled with hallucinated AI-generated legal citations. The AI just completely invented case law that sounded plausible. The SEC is stepping in, issuing new guidance requiring companies to submit interpretability reports if they use AI for financial forecasting. They want to see the training data to stop these black box algorithms from hallucinating massive growth projections and causing market volatility. It forces the reality that generative AI is a prediction engine, not a database of objective truth. Without guardrails, predicting the next logical word results in massive legal errors. The U.S. Patent Office also set a huge boundary today, officially rejecting AI-only inventorship. They ruled that a natural human person must provide a significant contribution, effectively halting an automated patent filing arms race where companies could just use agent swarms to patent every conceivable chemical compound. While the law moves slowly, cybersecurity is moving at machine speed. CrowdStrike just launched Project Quiltworks. Because frontier AI models can now scan code bases to find vulnerabilities, CrowdStrike is deploying autonomous AI defense systems to stop automated mass exploits. It is literal AI versus AI warfare on live production servers. Yet even with advanced autonomous defense, human operational security remains incredibly fragile. The Anthropic Mythos leak is the perfect example. Anthropic developed a highly restricted cybersecurity model called Mythos, deemed too dangerous for public release and locked down under Project Glasswing. Within days, it was leaked to the public. And the craziest part? It wasn't a sophisticated hack by a rival nation state. A private Discord group literally just guessed the deployment URL. They noticed a naming convention pattern from the recent Mercor breach, typed the web address into their browsers, and logged right into the most restricted cybersecurity model on the planet. We can spend billions securing the architecture of a model, but a simple human oversight instantly compromises it. This overwhelming need for trust is reshaping the tech sector. Perplexity AI just hit a $21 billion valuation, and they did it by completely sunsetting their advertising integration, shifting to a pure subscription model to maintain objective user trust. Contrast that with X, pulling out Grok-powered curated timelines for premium users, replacing community features with AI discovery to generate ad inventory. Google is trying to win the trust war through raw intelligence metrics. Their Gemini 3.1 Pro model just hit 94.3% on the GPQA Diamond benchmark. GPQA stands for Graduate-Level Google-Proof Q&A. It is a benchmark of questions so difficult that human PhDs, even with unrestricted internet access, struggle to score above 60%. Gemini hitting 94.3% means it is comprehensively out-reasoning panels of human experts across physics, biology, and chemistry. The models are hitting PhD-level reasoning. Yet within the corporate walls where these tools are used, human behavior is becoming completely absurd. We have to talk about token maxing. An AI token is the basic unit of data the AI processes, usually a word fragment. Token maxing is an emerging corporate trend where software engineers purposefully burn through massive amounts of tokens simply to rank higher on internal company productivity leaderboards. Because an executive installed a dashboard assuming the employee using the most AI tokens must be the hardest worker, engineers are running massive, unnecessary automated queries to inflate their stats. Ramp Labs reported a 13x surge in AI token spend, and Uber is blowing through budgets. Reid Hoffman publicly pushed back, warning executives to track actual outcomes, not blind token consumption. It is the digital equivalent of leaving your jacket on your office chair, so your boss thinks you're working late, scaled up by gigawatts of compute. And the tension of scaling this tech was perfectly captured by the pricing drama Anthropic just went through. They quietly hid their popular Claude Code feature from the standard $20 a month tier, basically forcing users to upgrade to a $100 max tier to use it. Users noticed immediately and revolted. Anthropic's Amol Avasari tried to claim it was merely a 2% test, but the community called it a fake door test, noting they altered public pricing pages and support docs. Sam Altman from OpenAI even weighed in, quote tweeting the drama with just 2 words, "Okay, boomer." Anthropic reverted the pricing quickly, but the friction remains. The standard model was designed for humans slowly typing queries, not for autonomous agent swarms coding 24/7 and consuming massive amounts of compute. Before we get into the final takeaways, just a reminder that you can find more insights, breakdowns, and practical guidance like this at inuku.com. If we step back and synthesize everything we have explored today, the juxtaposition is profound. The era of chatbots is over. The transition to autonomous physical and digital execution is here. We have an intelligence that conquered the physical constraints of an Olympic ping pong table. It mastered flawless visual text rendering. It evolved from single queries into swarms of 300 autonomous agents executing thousands of tasks simultaneously. It commands the power output of entire cities and has triggered a geopolitical talent war. Yet despite this godlike computation, we are still fighting over hallucinated legal citations, easily guessed URLs, and token-burning productivity leaderboards. As AI agents learn our exact keystrokes, dynamically design their own logic, and execute complex parallel workflows, the bottleneck in our economy is no longer how fast we can work. The new bottleneck is trust. When the cost of generating a brilliantly coded application or a massive legal vulnerability drops to absolute zero, the most valuable human skill left is our ability to verify what is real. Navigating that trust is the defining challenge of this new era. And that's your daily dose of AI know-how from Anuku.com, AI news you can use.